Okay, uh, as the three variables are co-integrated, co-integrated, we can run the VECM model, right? That we can run. Okay. Okay. Then we can run the VECM. So I go to quick. Sorry, I take it out. I go to quick. Then estimate var, right? And here I choose VECM. That I choose. And here the co-integration. Okay, so here the number of co-integration model is how much? 1. So it is already 1 is there, and the last time I choose number 3, and also I choose here number 3, right? The same thing, I'm choosing the same thing. So I choose the 3, right? Then I first put dependent variable, that is cons, that I do first, then GDP, and then I put export. So here what is happening, so the cons is the dependent variable, and GDP and EX is the independent variable. So cons, GDP and EX. And here I have chosen lag2, like Johansen test of co-integration. So here I am choosing lag2 as before. I am choosing lag2 as before, like Johansen test of co-integration. We chose lag2, and here I am also choosing lag2 because both model are system equation model. So I should use the same lag. So here I am choosing lag2, and so I can run the model. So this is my outcome of the vector error correction model, right? And here cons is the dependent variable, meaning that consumption is the dependent variable, and GDP and export are the independent variables. So the first one is this model, co-integration model, right? That is the number 1. One co-integration model is there, and here there are 3 variables: dcons, dGDP and dx. So it is the dependent variable dcons, and so that is the dependent variable. And the first variable actually our target model is the first one, not the second or third one. Our target variable is the first one, dcons. That is our target variable, right? Because here the consumption is the dependent variable, so the first one would be our target variable, not the second one or third one. This one should be our target variable. But here what is happening, suppose I talk about this one, 37.51. Actually it is the coefficient, and then it is the coefficient of this variable, and it is the standard error, and it is the t value. It is the t value, but here is no p value. Here is no p value. So but but I want to know what is p-value. I want to know what is p-value for each variable. Okay, so to know p-value, I use the system equation to know the p-value of each variable. System equation. Okay, so then what is the system equation? Okay, so system equation, I go to proc, then I choose make system, right? That is system model, make system, then order by variable, that I choose, then I press order. Okay. So yeah, so here you can see our three model. One is decons, the dependent variable, and dgdp, that is our dependent variable, and dex is another dependent variable. And you can see it is starting from C1 until C24, because the whole thing actually is the system equation model, and it is starting from C1, then C2, C3, then C16, C17, C21, then C24, right? System model. Okay, and here you can see three model number 1, model number 2, and model number 3. Out of these three model, the first model is our target model, because the cons is the dependent variable. So that is why the first model is our target model. And you can see from here to here, what is it? From here to here, what is it? From here to here, actually we call it, from here to here we call it cointegration equation, cointegrating equation when cons is the dependent variable, right? So from here to here we call it cointegrating model when cons is the dependent variables, meaning that from here to here the error term is here, meaning that from here we can get what? I'm writing here from here we can derive the residual of the cointegrating equation when cons is the dependent variable. From here means from here to here, right? From here we can derive the residual of the cointegrating model when cons is the dependent variable. Okay, the second step is so what I do, I select our target model, I select it, I select that our main model. I select and copy. I copy it and go to the quick estimate model. I go there and I paste it. Here I paste our target model. This is our target model, right? This is our target model, and I press OK to estimate this model. Actually, what is it? We want to estimate our target model. So I press OK. So this is the outcome of this model, right? So here the model, you can see consumption is the dependent variable, right? That is our model is here. Okay. Now here we have the short run and long run causality is here. Short run and long run causality is here. How? Okay. So suppose what is C1? C1 actually this one, the coefficient of the cointegrated model. That means this is cointegrated model, right? From here to here. So C1 is the coefficient of this cointegrated model. So meaning that from here to here until this cointegrated model, so that is C1. And C2, C3, C4, C5, C6, C7, meaning that here C2, C3, C4, C5, C6, C7. So these are all short run coefficient, right? These C2, C3, C4, C5, C6, C7 are short run coefficient. Okay. But you know what is C1? C1 is actually I call it, just I'm writing here. C1 means actually here, C1 is what? Speed of adjustment. Speed of adjustment towards long run equilibrium. Speed of adjustment towards long run equilibrium. But it must be significant. It must be significant, and the sign must be negative. So, but here the coefficient is not negative, but it is significant. It is significant because the p-value is less than 5%, but the coefficient is not negative. So meaning that the coefficient is not negative, meaning that there is no long run causality. There is no long run causality. There is no long run causality from the two independent variable such as GDP and EX. So meaning that our two independent variable such as GDP and EX have no influence on the dependent variable such as cons in the long run. In other words, I can say, there is no long run causality running from GDP and export to cons. So that is the outcome of this result, right? There is no long run causality running from GDP and export to consumption. Why? Because the sign is not negative. The sign is not negative, right? The sign should be negative and it must be significant. Yes, it is significant, but the sign is not negative. So we cannot accept the result. What is the meaning? Meaning that there is no long run causality running from GDP and export to consumption. So that is the outcome of this model. Okay, then I talk about short run causality, right? I talk about short run causality. So then I talk about short run causality. Short run causality, meaning that whether GDP and export have short run causality or not. So first I check with the GDP. Whether there is a short run causality or not. Okay, and here you can see GDP has C4 and C5. Here are two coefficients, C4 and C5, and here I shall be using the world statistics, right? World statistic to check the short run causality from GDP to consumptions. From GDP to consumption. And here, what is our null hypothesis? Should be C4 equal to C5 equal to 0 or not. That is the null hypothesis. If I cannot reject null hypothesis, if I fail to reject null hypothesis, meaning that C4 and C5 is 0, meaning that there is no short run causality running from GDP, so meaning that there is no short run causality running from GDP to consumption. If they are 0, meaning that there is no short-run causality running from GDP to consumption. Okay, so we run world statistics now, right? World statistics now. Okay, so I go to view, then coefficient diagnostic. I choose this one, then wall test, right? Wall test I choose. Okay, then what is our null? Should be C4 equal to C5 equal to 0, right? So that is our null hypothesis. Then I proceed with the null hypothesis. It is the wall test, right? And it is our null hypothesis, C4, C5, 0. And here I choose the chi-square statistics and corresponding p-value. The p-value is very small. How much is the p-value here? The p-value is around, p-value becomes 0.0008, meaning that meaning that less than 5%, meaning that 0.08%, and that is less than 5%, meaning that we can reject the null hypothesis. We can reject our null hypothesis, meaning that C4 and C5 is not 0, meaning that C4 and C5 is not 0, meaning that there is a short-run causality from GDP to consumption. So there is a short-run causality from GDP to consumption. Okay, so then we have some more model, right? So and we have another variable. The second question is whether there is a short-run causality from export to cons. So that is our second question, whether there is a short-run causality from export to cons. So that is our second question. And what is the result of the second question? You can see from here. So here, what is C6 and C7 are the export variable. So what should be our null hypothesis? It should be whether C6 and C7 is 0 or not. That is our null hypothesis, right? And here we shall use the world statistics as before. We shall use the world statistics. How? I proceed with the world statistics. I go to view as before. Then I go to coefficient diagnostic. Then I choose wall test. C6 equal to C7, right? That is our null hypothesis, C6, C7. Then I press OK. It is the result has come up, wall test, and it is the null hypothesis, C6, C7, 0, and chi-square value and corresponding probability. So the value is very small, less than 5%. So we can reject the null hypothesis, meaning that C6 and C7 jointly are not 0, meaning that C7 and C6 and C7 are not 0, are not 0, are not 0. So meaning that, what is the meaning of it? Meaning of it, there is a short run causality running from export to GDP. Okay. So what is our decision of the whole model? What is the summary of this model? The summary of this model is okay, number one decision, there is no long run causality from GDP and export to consumption. So there is no long run causality from GDP and export to consumption. So that is the first decision. And what is the second decision? There is a short run causality from GDP and export to consumption. So that is the second decision of this model, that there is a short run causality from GDP and export to consumption. Okay, so that is the final summary of this model. Okay, then finally we check. Then finally I check whether our model where consumption is dependent variable, whether our model where consumption is dependent variable has any statistical error or not. Okay. So actually this one actually our main model, right? Consumption is the dependent variable. Okay, and here what is happening? Whether our model where consumption is dependent variable has any statistical error or not. Okay, so the first I check R square. R square is how much? 63.39%. So so the value of R square is quite high. So we are happy about the model because the value of R square is 63.39%. And what about the F statistics and corresponding probability? Yes, the F statistics is significant. So we are also happy about this model. Then finally we check our I go to view, I go to the residual analysis. So first I check serial correlation, right? Serial correlations. So I choose lag 2, and here you can see the serial correlation, but the thing is that the p-value is less than 5%, meaning that we can reject the null hypothesis, meaning that this model is suffering from serial correlation. So that is not desirable for a model, because we can reject the null hypothesis. So meaning that this model has serial correlations. So that is not a good sign of this model. Then we can check about the residual diagnostic. We can check about test of this one. We can check this one, Heteroscedasticity Test. And here I choose the Bruch-Bregan, right? And here you can see that I choose the observed R square, right? And what is the p-value? P-value is 44.11%, meaning that this model does not have heteroscedasticity. So that is a good sign of this model, because this model does not have heteroscedasticity. Then finally I check the test of normality, right? That is the third one, test of normality. And here I check the Jarkabera statistics and the p-value. How much is the p-value? 96.72%, which is more than 5%, meaning that the residual of this model is normally distributed, and that is what? That is desirable. That is desirable. So in this model there is only one problem. There is only one problem. That is the residuals are serially correlated. That is the only one model. That is the only one problem of this model, and that is not desirable at all. That is not desirable at all, and we cannot accept this model because the residuals are serially correlated. That is really bad.